Good morning, everybody. This is Nick. I'm the Raging Cajun from the University of Louisiana. And in this video this morning, I will describe the EPS, electronic power systems, that we plan to fly on our next satellite. First of all, let me say what the mission of the EPS is to collect all the energy we can from the sun, and number one, supply it to our load, and take the excess energy and store it in a battery. Of course, we want to do this as efficiently as we can. So let me get started and tell you about our system. First of all, on our satellite, we have 4 surfaces to put solar panels. So we will do that, and we will then route these to a peak power tracker, and then to our loads and our batteries. So let's start with one of the surfaces. So here we have solar panels, and of course we have to put cells in series and some in parallel. Now the cells in series have to be identical. From there we go to an ideal diode, and this may or may not be necessary depending on what kind of power tracker we design. Of course, we will put temperature, voltage, and current sensors on this panel. But in addition to the solar panels, on this surface we have to make space for our sun sensors and our burn resistors to deploy antennas. To do this, we will put our sensors and our sun sensor and our current voltage sensors on an I2C bus. We'll also have to route this to the solar panels. And of course, we got to be very careful that all of these things have wires, and as we jam into the satellite, we don't want to create a fuzzball, so we need to be careful about how we design and deliver power to and from those sources. Now, from the peak power tracker, we parallel up all the 4 surfaces, and we then hook to our batteries and our loads. And of course, and we put switches to kill all the power to the satellite, and that's this switch here. And we're also able to switch on and off our batteries. In our design, we choose to put 2 1850 cells in series to give us roughly an 8-volt bus. And we will route that to buck down converters to get our 3.3 volt bus. And we also supply a bus of the direct battery voltage, which we call the unregulated bus. We may also, at this time, design other up or down converters depending on what the payloads we tend to fly. In addition, in our board, of course, we need high current switches to switch burn resistors on, and we may or may not fly a processor to do this. In addition, on our satellite system, we will put programming interface via a CAN bus. And of course, we need a watchdog timer. Let's see if I'll put that in this circuit. We need to include a watchdog timer in this on this board, and of course, by a lot of constraints, we actually have to have 2 additional disconnects. One is the remove before flight disconnect, and the other is the separation switch, and this drives our watchdog timer. So in the next video, I will talk about what we plan to do, or one of the options we plan to do in our peak power tracker.